When we need to find a Taylor series, the first thing to do is probably to list the derivatives. So there's a bunch of the derivatives of f of x. And so now we start applying the formula for a Taylor series. It's the original function at the center that we're given. Here. Plus the derivative, which is negative 4 sine at our center, pi over 2, over 1 factorial. I mean, we know 1 factorial is just 1, but it's going to help us find the pattern if we keep that as 1 factorial. And then the polynomial starts. It's x minus pi over 2 is our center. That's to the first power. And then plus the next. So the next derivative is negative 4 cosine pi over 2, and it's x minus pi over 2. Now we're squaring over 2 factorial, and then it's plus, what are we on, the third derivative? So it's 4 sine pi over 2 times x minus pi over 2 squared over 3 factorial, plus the fourth derivative is 4 cosine pi over 2 times x minus pi over 2. That should be, let's see, first, second, that one should be the third power, right? This is the fourth power over 4 factorial. And then I've listed out one more. You can keep going if you can't see the pattern after a while. And you'll want to wait. If we're not looking for the pattern yet, we want to simplify because of these centers, and then we'll try to examine the pattern. Okay, so we got the Taylor series terms written out. So what I'm going to do is I'm going to start simplifying. Cosine pi over 2 is 0. Sine pi over 2 is 1. So this is negative 4 times x minus pi over 2 to the first power over 1 factorial. Here, I'll cross these out too, the ones that turn into 0, because look, this is also 0. Cosine pi over 2 is 0. This next one is 4, it's 4. Sine pi over 2 is 1. So then we got x minus pi over 2 to the third over 3 factorial. Cosine pi over 2 is 0, so that's gone. And then here we have negative 4. Sine pi over 2 is 1. That's the whole point. We're simplifying, so I shouldn't have been writing that down. So this is to the fifth power over 5 factorial. So that's enough to see the pattern, okay? Because what's happening is it's alternating, negative, positive, negative. So when we write our series from n equals 0 to infinity, we want an alternating term, and I'm going to use n plus 1 here, because when n equals 0, we get 0 plus 1 makes 1. It's a negative term in the series. When n equals 1, then n plus 1 gives us 2, so negative 1 squared gives us positive 1, which is the positive term that we're supposed to have. Okay, and then let's see what else. We could put the coefficient of 4 right here too. They're all getting multiplied by 4. Right, and then up here this is going to be x minus pi over 2, and the power goes from 1 to 3 to 5, so the power keeps increasing and it's odd numbers. So 2n plus 1 is how we write odd numbers in the shortest way in math. And look, you can check that to make sure it works. If you plug in 0 in for n, then you get out 1 for the power, which is what we wanted. If you plug in 1 in for n, then you get out 3 for the power, which is what we wanted. And also the same thing on bottom here. This is 2n plus 1 factorial, because we want an odd number, next odd number, next odd number. So if you plug in values for n, you should see it spitting out the correct odd number, and then it uses the factorial. So that's your Taylor series there in the bottom right.